So, during this video what I want to do is basically go through the first question you were given in task 1. So what we'll do first is we'll read through the question itself. So as we can see above here, ABP represents the sector of a circle that is rolling without slipping around the outside of a fixed circle. So we know that ABP is a sector, so that we know then so that A is the centre, and if we extend our compass from A to B and swing a circle, we can find the full circle itself. So there we go. Now if we read on, point P and point P1 represent 2 points on a fixed circle. So P and P1 are 2 points on a fixed circle, the centre of which lies along the line PC. Okay, so what I can do here is I can join P and P1 and basically get a chord. And if I bisect a chord, what I can find is the centre, and if I do a perpendicular line through that central point, where it intersects P and C will be the central point to draw a circle that will travel through P1 and P. So extend here. So, extend here like so. So as you can see here, this is going to be 90 degrees to that particular line, PP1, where our new line here intersects the line PC should be the central point for a circle that travels through P and P1. So now if I extend my compass out to P1 and draw the circle, it should go through both of them, yeah, like so. Now I don't have to draw my full circle, I'm just going to draw as much as I can fit on the page, like so. Now that I'm at this point, I'm just going to read on a bit further. So, the first question, establish the central point of the fixed circle. Okay, so I have that found, that's here. This is the fixed circle, so this is the central point. Circle, like so. Now if I read on, plot the locus of point P for one full clockwise revolution of the rolling circle. So we have point P here. This circle is going to roll one full revolution along the circumference of the fixed circle. Construct, and then last we have to construct a tangent to the side line. Okay, so we have the first part here done. We have 2 marks gathered. Now we need to get our 5 marks. So what I'm going to do for this is I'm going to divide this circle up into 12 equal sections. Now you don't have to divide into 12 equal sections. I just like to divide up into 12 equal sections because then I can see clearly spaced points all the ways for the full revolution. So this means I'm going to be breaking it off into 12 different sectors. We have one sector here. We'll just finish off now and get our other 11 sectors. Now as you can see that I'm going to actually divide it up as if point P here, a tangent to point P, was the ground line. So if I get this set up, Now, so I have my 12 different sectors. So what I can do now is I can start labelling them. So if I start labeling them clockwise, so we have P, P1, P2, P3, P4, P5. Okay, so what we can do now that we have them marked, we can start drawing where our centre of our circle is going to constantly be, which is going to be along an arc from, I suppose, the distance from the centre point always to A, an arc that travels all the way across here. The central point of the circle is always going to be along that path. So if I extend out my compass, like so, draw that arc, that my point A will always be travelling along. Now I need to find out how far this circle is going to travel in month of revolution. So what I can do is I can extend my compass from P to P11 here, and then just get the distance of one of my sectors and basically mark that distance off 12 times along here for the 12 sections. Okay, so that's my 12 different sections. What I can do is label them now. And just want to start calling it Q1, Q2, Q3, Q4. Okay, now that I've them marked, what I can do is I can extend my line from the point here, my fixed circle, through each one of these points I've just identified, like so. Now remember that all the lines that I'm drawing here are fairly heavy, just so that you can see them through the visualizer. I would suggest that any construction lines that you're drawing, just keep them nice and light. The main thing is just to ensure that all your points are annotated. The reason for this is just finding your points would be a lot easier then when it comes down to it. So if I start labelling all the points inside here, where I suppose the centre of the rolling circle would be at each quarter, or each sector as it moves, as it rotates along the curve. So I'm just going to call this A1, A2, like so. Now what I can start to do is basically my triangulation to find each point. So I know as my circle here starts to rotate, so as, let's say, P1 hits Q1 here as it rotates across, P will now be in the location of B over here, but the circle will be moved across. So what I can do is take my distance from P to B, like so, go to Q1, draw an arc. Then I can also get my distance from the centre A to B. So you can see here, which is also P1, and go to A1 and draw an arc. And where that intersects is our P1. I'll put it right here so it's nice and clear. Now I just keep repeating that process. So this time it's from P to P2. Draw an arc. So two. P to P3. Now for P6, I know that's going to be straight up at this height, so what I can do is I can just extend my line to P6, which is going to be here. Extend that out like so. Get my compass, take the distance from the central point all the way up to the very top. My compass actually doesn't reach, so what I can do is just take the measurement from P to P6 and go from P6 outwards, same thing. And now I get my point at the highest point of our cycloid from the central point of the fixed circle. So if I just mark in here P6, what I can do now is I can continue on the epicycloid as it's travelling across over here. Now what it's going to be is the mirror image of everything on this side across here. So if you've noticed there is something wrong with your curve here that doesn't seem that's building up like mine is here, more likely you got one of the points mixed up. Same thing over here. If there's something wrong over here and it doesn't look quite like the other opposite side, then you've missed the point somewhere or put it on the wrong position, which has affected your curve itself. So we'll continue on now with P6. So P to P7. P7. You can see how P7 is the same as P5, mirrored. P. Same thing with P8 and P4. So you can see here now I've all my points, so what I can do is draw my curve from my epicycloid. as you can see here. So now what you've completed is your section 2 here, and now for your last section, which is construct the tangent in epicycloid. All you have to really do here is for any point on the curve itself, for instance P6, where, let's say if there was a circle formed for where P6 was, so for instance here at P, all you have to do is draw a line from where that circle touches, I suppose, the fixed circle here. So for instance, for P4 touches fixed circle, the circle there at Q4. So if you draw a line from Q4 straight through it, like so, you have a normal. Then all you have to do is go 90 degrees to that. Like so, and you have a tangent at that particular point. So if we repeat that over here for, let's say, a P8, if you go to P8 and where P8 circle touch is the actual fixed circle, so P8 and P8 over here, so if we draw a line through that, that's our normal again, through that point. And if we go 90 degrees to that perpendicular line, now we have a tangent here to P8. Now that's